Welcome back to the workshop. So in the last episode we managed to get these DROs fitted, so really pleased with that. So in this episode we just got lots of little jobs to do. So we've got an end stop, cover plates, lock mechanism. So let's get started. So we need to make an end stop mechanism that stops the table coming too far this way. We need a lock mechanism that locks the table from moving left to right, and that has to be a bit custom because the DRO partially obscures the hole that the lock goes into. And then finally we need to make some covers or modify some covers to go on here and one over here, and this one here has to have these protective shields clipped into it in some way. So there's lots of little bits and pieces to get made, lots of little detail. So cue the montage. Here we're machining down quite a large steel block, just only need a little piece of it really, but that was all I had. And this is going to become the X lock mechanism. To be honest, I wasn't super happy with how this all turned out, and I might make something different, but it'll work for now, or it'll work well enough for now. And then I'll see if I can come up with a better idea. As you'll see when we come to assemble this, I wasn't overly happy with the design, but it's a start. And here we're turning the end stop just to make sure it doesn't move too far, so nothing too fancy there. And now we're machining down the X cover. So this needed to be machined pretty accurately because it would rest up against the side of the table, and if it was out of line it would show in the gap. Okay, so we're a fair way through building all the parts we need. So we've got two locking mechanisms. These are temporary, I'm not sure if I like these or not, but these will be for the X axis. These two in here, got a spare one there. This is the lock system, which I'm kind of okay with. Again, I'm not super happy, but I'll show you that in a minute. That's the lock for the X-axis system. There's quite a lot of workarounds there to make that work. I'll show you that in a bit. Then we've got the cover for the DRO, and then there's some little clips around here that hold the cabling on, and we've got the cover for the other DRO here. Then this last one here, this is the lock mechanism to make sure the table can't move too much in Y towards the front, so that locks that movement. It's just some cable ties to tie up some of the DRO cables as well. So before we go any further with this, I'll just show you the machine because I've decided to change something I made earlier. Let's head over there now. So what I've done is move the table all the way over to this side, and the furthest it will go, and then under the table, and then slid it back. So the table is now here. I've got some marks on here, so when that lines up with that, we're furthest that way, and when the other end of the table lines up with that, we're furthest that way, so we know our limits. And basically what I had on here was this little part I made in an earlier video. It's been cold blued as well, which is why it's so dark, but that basically went on the end of there. but it wasn't stopping the mechanism. Essentially what's happening is it's just pushing under the seal and allowing the table to go too far. And then with the DROs on here, it was causing the DRO to move further than the reed head would allow in the travel in the slots. Obviously it was going to damage it. I was always a bit unhappy about the fact it pushed on the seal, so we're going to make a new one of these. So I've got a quick sketch down there, as you can see, nothing too fancy. Be made out of mild steel, and then we can cold blue it again as before and stop it rusting. So I've got some stock in the lathe, let's get going. So we start with the usual process of just facing off, just to get a nice clean edge. Then I turn the outer diameter down, and then, well, I could have done this a couple of ways, but decided to put the chamfer on now. So I could have done it after I parted it off and turned it around, but this way it keeps it more concentric. Not that it's that critical, it's only a decorative feature really, but since I was here I did that. And I drilled out the centre for clearance for the M5 screw. That's the screw that holds it onto the end of the ball screw. And then we're counterboring here, and yes, this is a 2-flute router bit. That's just what I had to hand to get the job done. And then finally we parted it off. Okay, here's our finished piece. So we'll just do a quick check to make sure that's going to fit on there. I'm not going to do it up because we need to take everything apart even more. Yeah, that's going to work fine. Right, next thing we need to do is take this off. Now I've got this adjusted all the way as far as it'll go this way, and then I just made a mark down here, and then I know it's 137mm between here and here. So we'll take this off here, off the ball screw, take this off, and then that will leave the ball screw exposed, and we know that's the maximum it can go that way, and then we know it can go 137mm the other way, because we're going to have a look at some covers. Alright, hopefully that should come off now. I seem to spend more time stripping it down, rebuilding it, than anything else. Anyway, there we go. Trying to drop it. And we're left with this. So I made this little paper template, so hopefully, see if that fits. That's pretty good. Goes from there to there, and then that's got to move 137. Yeah, it's going to just clear it. Alright. And then on top of that will be this sliding one, which will sit like that, and will catch on that front edge to push it this way, and then on that bit will catch on that back edge to push it that way. That's the plan anyway. So we need to make this, I think, out of some 1mm aluminium. So I need to order some material, and then we'll get cutting that out. Okay, so while we wait for the aluminium to arrive, I thought we may as well cold blue some of these components that we made earlier. So we've got this piece, which is the end stop for the Y, so that stops it moving too far front to back. And then we got a part of the lock mechanism. I'm not completely happy with the way this works, but it'll be good enough for now, and maybe we'll come up with something a bit better. But we need to treat it, stop it going rusty. And then finally we've got this one, which is the end of the ball screw that stops the ball screw moving too far in Y. So this is the larger version that doesn't go past the seal. So we'll clean them up. We've got a bit of terps. So just get all the grease off, and we'll clean all that off, and then we'll get the cold blue on, and hopefully that will keep the rust at bay. So we'll degrease these first. use anything to degrease these really, all sorts of solvents. And I'll just try not to get my fingers on them once they are degreased. Okay, I think they're pretty clean. Next up we've got our cold blue. I just bought this off eBay. I think it's some pretty good stuff. I don't think it's very dilute. You can dilute it with water if you like. I tend to use it neat. Don't use too much of it. I'll just get those dipped in there. Turn that one over. Come back in a few minutes. I'd say they're about done now. Just by the way, I've got safety specs on. You really should wear gloves with this. I'm just usually very careful, but ideally wear gloves because it's just got lots of nasty stuff in it. It's pretty strong. I think phosphoric acid. Yeah. So take all the precautions you feel are necessary. So I've got some water in there. We're going to rinse that off now and then dry it, and then we'll put some oil in, and hopefully that will be that. So now they're dry, a little bit of oil. The one I'm not too sure about and I might remake or redesign, it's actually turned out really well. And the one that I do like, that's the new end stop. Wasn't quite taken, maybe it wasn't ultra clean. Yeah. Okay, well it'll be inside underneath the XY table, so you won't see that. And then here's the end stop for the Y. And this is on the outside, so you will see this. And actually that's worked really well. So you'll sort of see it, that end on. That looks nice. Alright. There's our three pieces, machined and cold blued. So that's that one. I think I'll get a dome sort of mushroom one, yeah, that sort of style bolt for that, but I haven't got any left, so I'll do that later. That's the lock for the Y, and that's the end stop for the ball screw. Okay, the aluminium that I ordered just to make this cover plate here and the sliding bit in the middle, it's arrived. I've got it set up on the CNC machine. Just give you a quick overview of what we're trying to do here. So I showed this earlier, this is the paper template. This is going to be the main fixed part, and then there'll be a sliding cover that goes in here that will cover the gap and slide backwards and forwards, and it'll be pushed along by this, so it'll be sort of that wide. And then you may be able to see a couple of these holes marked out all the way around here. I'm hoping to use the minimum number of holes because basically each of these holes ends up being drilled and tapped into these dove ways down here. I don't want to put too many in because they're going to be right into this section. So I'm just going to start with the 4, and then I'll mark out the other ones just with a small witness mark on the CNC machine. And then if it's too bendy or vibrates too much or lifts up, then I'll have to see how many more I want to put in. But I'll mark them all out and then just take it from there. Yeah, I'm just starting to set the piece up here now. The main plate will be, you can see I've marked it out, be sort of that sort of size, and then there's that hole in the middle. It's a little bit wide. I could have done it the other way around, turn it 90 degrees and cut both pieces out, but what I'll do, I'll cut the main piece out, then we'll make sure we've definitely got the right range that I think we've got in CAD, and then I'll make any adjustments and cut the kind of sliding piece out the other side and move that over here. So we'll just focus on this main piece, getting that right first. Now what I've just done is move the machine down to just below the parts. That's as low as it's going to cut, and as you'll see up here with this little marker, we're almost at full depth. Now that would probably just about do it, but I'm a bit nervous about being quite that close to the full travel. It's probably got about 1 millimetre or so, and I might have put a little bit over cut in the cam, I can't quite remember, just to make sure it went all the way through. So I think what we'll do, we'll adjust the spindle. That's what it's for. It's fine when you're doing this very thin stuff, and then we can get going from there. So the spindle itself can slide inside the bore. There's an 80mm bore inside this main block here, and there's like a strap clamp, if you like, across here, and then there's one you can't quite see, but it's a little bit higher, so it's held in place by those two. So when I loosen those, I can move the spindle down. So just loosen these a bit and hold on to the spindle because it's probably going to drop. Alright, and then we'll just raise. Alright, and we can only reach this one, so we do that up. Then narrow over a gap in the table. There we go, got access to that one. Alright. Okay, and there we go. So the reason just for showing that was if you're building your own machine, or you design your own one, or maybe you got one and you're thinking of upgrading, just bear in mind with these round spindles, if you can have some adjustment in the clamp, that covers the extremes, because otherwise you end up with a very compromised machine. You'll end up with the gantry being really high, a really tall Z to reach down, but then when you don't need all that reach, maybe you've got a loss of stiffness from that. So I went for this kind of compromise where I've got a reasonable gantry height, and then I've got a little bit of adjustment if I've got really thin materials, or if I've got something in a vise that's really tall, I can slide this up and sort of adjust my travel from there. So it probably gives you about another 30-40mm of up and down travel over and above where your Z-axis would normally be. So worth bearing in mind with anything you're designing at the moment. Right, let's make sure this fits on here. I'll run around the outside, make sure it follows the cam lines, and I've got a good zero, and I'm not going to hit any of the clamps, and then we'll get going. One more thing that's worth bearing in mind, this is 1000 grade aluminium, it's almost pure aluminium, and that makes it really easy to bend. The downside is it's really gummy to cut, and it often gums up the cutters, and if you're not careful it'll either move your work or jam, stall and break the cutter. So I'm going to be using an awful lot of WD-40. When I'm cutting, I may deliberately not put some on, and you can hear what happens to the spindle after a few seconds and hear it bog down and threaten to stall. So if I'm brave, I may try that, but my method is to absolutely flood it with this. Now I was given some advice a long time ago about you can cut this in one with a roughing cutter. I've just never got around to buying one. I'm sure that's a great thing to do, so if you're doing this, then by all means go for a roughing cutter first. I'm just going to go for this. I can't remember if I did it in 1 or 2 passes on the cam, did it a while back, but let's get it set up. Plenty of flood coolant, it loves to gum up, so let's hopefully don't get in that situation, and then should cut it out and then we can clean it all up. Right, before we start, I just thought I'd show you I'm doing an air cut here. So basically I've set the Z above the workpiece, and then it's running around doing that. And one of the things I thought I'd show you is I've got a feed rate override here, and what that's doing, as you can see, so I can change the feed rate with that one there and just dial it in to perfection. And now what that's actually doing is see if I can open it up here. On the analog in, pin 11 I think it is, or sorry, it's analog in 1, analog input 1, yeah, the one about there. I think it's that one that's receiving that signal. Go and have a look in the manual if you're interested. It's a very easy thing to implement. Right. Oh, and I think it's finished. So that traced the outline quite nicely, it didn't do anything unusual. Let's cut it out. Actually, that went pretty well. That's a brand new aluminium cutter, so it's got a 45-degree angle on it. It's a 2-flute carbide, specifically for aluminium. It's very sharp, and I think, as you might have seen, part of the way through that, because this is quite thin, it can lift up, and then it was ending up cutting not at the tip, but part way up the spiral, which I think actually helps as well. So that went fine. I think what I'll do, I was thinking about lowering the Z and just taking off that last bit, but I think what we'll do the finish pass, which is at full depth anyway, and we'll see what's left. I might just lower the Z ever so slightly, maybe 0.1, run the finish pass, and then that'll be that. As you can see, this is just a bit of chipboard. If you're doing this, you want some real precision, you got something with a bit of depth, you'd skim this first so it's definitely flat, but for what I'm doing with a bit of sheet material, yeah, it's not really going to matter. So let's finish this out, and then we can cut the centre out, and then we're done. So let's peel it off and see what we've got. Okay, well, moment of truth, let's go and see if it fits. Okay, I think it goes on with the short bit at the front, yeah, like that. So at the moment you can see I've got 4 holes drilled, and then the rest of them I've just got little witness marks, because I'm just trying to keep the holes to the minimum. Otherwise I'm going to drill into this dovetail way on either side, and yeah, maybe start to change the shape a little bit. I mean, not too critical on this, but I want to just keep them down to a minimum. So we'll just try all 4 to see how kind of springy and bouncy it is. Might get away with it. Yeah, the other thing to note is, so obviously this is sitting down a little bit under gravity, but it'll be a little bit higher when it engages into the carriage there. And it looks like I've just got to file out those corners. I thought I'd have to do that, but that's fine. I'll file those square, then I can get maximum travel. Apart from that, yeah, looks good. Okay, let me file out those corners, and then I'll bring you back. Okay, yeah, it's nice and square. That clears. So I think the next thing to do is just centralise this so it's the best fit, because it's a slightly rough casting around the edges. Get it about as square as it's going to be. Then we'll mark through these, drill and tap. Now, what I was hoping to use is these little M3 countersunk screws. Now, I may need to cut them down a bit. We'll see, because I'll end up going a long way into the ways there. So I think I will cut them down. Also, obviously this being countersunk, I'm going to have to countersink slightly into this, because that countersink will, to make sure this is definitely flush or underflush, countersink itself is going to go through this 1mm sheet. So a little bit of fiddling about to do there. We'll get that set up, drilled and tapped, and then we'll bring you back once we're putting it kind of together. Once I've got this one working, I know I've got a bit of a feel for how deep to go and which countersink to use. Yeah, I think I might go with that. Looks alright. Alright, we'll repeat that 3 other places. Okay, so as you can see, I've got it bolted down at the 4 corners now. Now to get the drill in back here, I just couldn't get it in because the rails are in the way. We're at quite an angle. So I had a couple of options. I thought I could re-drill the hole further inboard, and then that would be easy. I didn't quite like that. It would look a bit asymmetric, and then I'd end up with a hole that was clearly not used. I couldn't quite get into those as well. Should have thought a little bit ahead, but anyway, that's where we got to. So one thing to bear in mind then is, well, what I ended up doing is taking this off. So I took this off, and then that gave me access to the 4 big M12 screws that hold it on, and then I took it to the workbench and I had plenty of access, and I drilled it. It does mean in the future, if I ever need to drill something that's really deep, the idea was I'd be able to just take this off with 4 screws, take it to one side, and then I'd have access to the table, or I could just take the table off the top piece, which is a couple of screws, and then have the full height of the drill press from top to bottom. That was just to give me options. Now in this way, if I put these center 2 in with the table on, I've just worked out it comes to about here. I can't quite get to these, which means to ever get this off in the future sort of quickly, I have to pull, sort of half disassemble it. So I have to pull the y-axis off, or at least undo the end stop, undo this, allow it to come a long way forward, then undo these 2 screws, and then I get access to these, pull it all the other way, get those, take this off, and then I can get access to the screws. So yeah, it's a little bit fiddly. So what I might do is just run with it without those in for now. The drilled tap countersunk, so I can add them at any time. And basically it's just to hold this in place, see if it rattles or if it picks up and rubs too much against the y-axis. Then I might have to put those in. But I'm going to leave them out for now. You won't see it because it'll be covered. And it means if I need to take it off, I can get access to these for slide the plate out and then undo the bolts and take the whole thing away. So that's what we're going to run with. Yeah, I didn't film it because it's very similar to this, but I've just machined this. This is the sliding cover plate that goes on here, and that fits just like that. And the idea is that this is fallen down a little bit under gravity, but this will be bolted to the y-axis, and it will pick up either on this front edge here on the bonnet, yeah, you can just see there, to push it that way, or it will pick up off that back edge and slide it that way. So if we just, it's not going to be easy to demonstrate because the bonnet is too low. Effectively it will be like that, and the y-axis covers this hole in the middle, so that's not exposed. It'll get to about there. Now at the moment it's going to go underneath, so we just need to, I don't know if I'm going to be able to do this. I'll try. No, hold on, I've got an idea. I'll just pull it up. So in that way it kind of covers the whole range, and basically the only thing that's going to keep this in place is the fact it's trapped in there, so it should only be able to slide backwards and forwards. It might be able to move side to side ever so slightly, but that doesn't really matter. And then see, if you lift this end up, you'll see it's just about covering that hole when it's fully that way. The only thing to say is when it comes fully forward, if we can, I'll just simulate that. Which will be somewhere about there. Yeah, you can just about see it in shot. It will stick out a little bit, so the y-axis actually comes slightly this way, just to give you the maximum travel. But I did check, and it's going to be nowhere near the handle, so that's okay. So I think that's going to work. So yeah, I think the next thing to do is to put some of it back together. So I think we'll start with the y-axis and the gib for that. Okay, so here's the y-axis, so we'll get this on, get it in a position, then we'll get the gib in. Be careful because the DRO is down there. Right, let's get the gib in place. Okay, I'll make sure it's got plenty of oil on it. It's horrible, isn't it? Yeah, I know, one day. Right. Alright, now for the tricky bit, which is I've got to get this onto the block without kind of pinching or sandwiching that in there. It needs to be either side, so I guess we'll get it started and then just see where we get to. Right. While we're here, you can see this is the new, much larger end stop. So before I forget, let's tighten that up. So as you can see, it's a much larger diameter than before. That's pretty tight. And rather than pushing on the seal, it now comes to rest against the housing, so that's full travel. You can't accidentally unwind it, which would be very bad. Right, let's just check we're clear and then we can tighten these up. Okay, I'll just have it loose for now so I can play around with it. Right. I suspect that's getting caught. Yeah, well, there's witness marks there. Okay, if I move the table all the way that way, you can see it sticks out at the back, so it's dragging a little bit, and then when it hits there, it's pulled. So you've got these witness marks here, and it's pulled it a little bit too far, and it's dragging when it goes there. So, just thinking about it. Right, as you can see, I've had to take it off again. So basically, it wasn't running very smoothly, and you can see it was starting to gall and pick up. I wondered what was going on, and the answer is this is upside down. So this is the bit that the ball screw nut clamps onto, and obviously all of this is supposed to be considerably lower, so there's clearance for it to slide. Now, there's maybe 1 or 2 millimeters, which is maybe a bit more, which is okay, but when you go around this front side, it's almost the same level, which means this would be like that. And the idea is, yeah, the block sits in there and just moves it backwards and forwards like that, but I guess it's catching on some of these. I might be able to file it down. Yeah, if I had a die grinder, that'd be good, or I have to go back on the CNC machine and I have to relieve some of this. Well, as you can see, I decided it was far too much to grind off with the grinder, so we got it on the CNC machine. It's on some, not parallels, but some pretty parallel blocks down here just to raise it up a bit so it's not on the ball screw. Clamped it down, blocked it in, and we'll just mildly machine that little bit there. Just take it down a bit so it's definitely below that by at least 1 millimeter, probably 2, just to give some clearance. Right, so I might need to move this clamp a little bit and we'll see. Right, let's get going. Right, the other thing I did is machine this little island down because I realised that was probably too wide as well, and this way. Then that makes sure that's in contact with the block, and the block itself is bigger than that, and then there'll be clearance for that little sliding cover to slide. You can see that it's actually machined quite a bit away to give that relief that we needed. I didn't go any further out because the cover's only sort of that wide. You know, I was tempted to make it look nice, but you won't see it, and it doesn't really add anything back there. So we'll unclamp this and clean up all the edges, and then we'll try it again. Right, so I've just put it back together, and as you can see this time, the little cover can slide. So I haven't got the block tightened up, but that's, yeah, it's got a bit of clearance this time, so yeah, hopefully that'll work. Right, let's get all this together and then we'll bring you back. Right, so I've got the ball nut tightened up there, and now you can see this is loose and free to move. So we'll bring it this way, and what hopefully you'll see, yeah, So it stays where it is for now, so that's taking up the gap, and then somewhere around here it will pick it up and move it this way all the way to the end of travel, which is somewhere about there. And around the back here you can see that it's still covering up that gap, and then when we go back again it picks it up about here somewhere. There we go. And now if we keep going all the way to the end, now this won't fully go to the end, there'll be a millimetre or two because I need to put a cover on the back here for part of the rear protection. We'll go to about there. I don't know if we can see. Yeah, just about see it. Just about covers that hole there. So that's kind of where it'll sit. Now I thought about putting some little felt wipers on there just to keep some pressure. I don't know, is it maybe going too far? Also thought about having this run with some little rivets or something like that ran in some channels, but you know the rivets are then, the channels can allow the swarf to go down, so I thought, you know, let's just keep it simple like that. It'll keep the worst of it out. Anything that does finally make its way through will be very, very small, and it'll probably fall under the ball screw and just sit at the bottom, or it'll fall out that hole we drilled right at the bottom there. So I think for what that needs to do, that's okay. And most of the time it will just sit there moving backwards and forwards, and you'll have something up here that you're working on, you won't even notice it because the DRO will be here. And as I say, there's going to be some kind of rear cover at the back here. I haven't quite fully decided. There we go. Now I was going to rebuild all this, put the table on, put the DRO back on, get this back on, and then show you the lock-in mechanism that goes in here. But what I've realised is that to do this rear piece back here, that I'm just playing around with a few ideas. It's, you know, you see on a milling machine you have a kind of bellows, or there'll be a leather sheet or plastic sheet or something like that. I'm going for something along those lines. The problem is it's got a concertina or collapse down very, very small, so when this is right up and allow the quill to move, because it's going to come off the back of this plate here, it ends up being a very small gap. So I'm just trying to work out the best way to do it. If you buy the regular bellows, they'll never compress that amount, and then it's got to allow the table to go all the way down to the bottom and then still cover that and stop stuff getting in there, and allow the table to go fully rearward. You know, a lot of the solutions end up crunching or scrunching up the kind of leather shield or plastic shield, and I think in my case I'm gonna run out of room. Well, I think I am anyway. So I'm just contemplating it, and whatever it is, I'm probably going to have to pick up some holes that I need to drill and tap in the back of this, so this will have to come off. So rather than rebuild it, I thought we'll stop it there. I've got all the hardware basically made, the cover's made, but let me come up with a solution there, get that sorted out, or at least drilled and tapped ahead of time, so when this goes together, it goes together for the last time. And then also next time we'll be able to fit all this hardware back on again. These are all the end stops, these are the cable guides for the DRO, for the outer screen to be protected. That's an extension nut, if you like, that turn, because access is very limited behind there. We've got a selection of locking screws. I've got some new ones that I ordered. They're a bit more expensive than I thought, than I usually pay, but I thought, oh, I need them. And I'm glad I did, because the handle is aluminium die cast, so we've got those as locking bolts instead of these older ones that I've got, which are plastic. I just assumed they were always plastic, so that's nice. And then we've got these locking ones again for the other axis. This is the X-axis lock system. I think I'm going to remake this bit. I'm not very happy with how that turned out. I think I can make that function a bit better. So I'll do that before the next video, and then you can see it all put together and see how it's going to work. Then we've got the shield. I've just got to trim that down to length, but basically that's ready. And then this is all done. So we'll put all that stuff on next time after I've figured out the screen or shield system I'm going to work out at the back of the table there. So all that remains to be said is, once again, thank you very much for watching, and see you next time.